picture of you. Do I see Laia? I see Laia. Okay. So welcome everybody and good evening. You will keep on hearing this sound, tin, tin, tin. There are people entering into the online platform to follow the lecture. First of all, welcome to IAAC, but more than anything, welcome to our houses, because this is where we all now are, and we are hyper connected from our homes, both working as well as organizing all the events that IAAC has been planning for the last months. So today we are starting with the opening lecture of the spring term, the spring term of lecture series at IAAC, and we are more than happy to do that with the lecture of Laia Romero. Laia, today we have at the moment more than 130 people connected with us all to hear what you have to share with us. I just wanted to have a very short introduction about Laia Romero, but before that, explaining you shortly that the way that we are going to coordinate the interaction in relation to Laia's talk is that you can all use the chat to share your questions during the talk of Laia or at the end. I will try to moderate as best as possible and try to address some of the questions. And at the end of the talk, we will also have 15 minutes for a more direct interaction with everybody that is interested to ask anything to Laia or share anything with her. So starting a bit, a few words about Laia Romero. As you probably know, she's the managing director of Lobelia Earth. Lobelia Earth is a pioneering company that is using Earth observation satellites in order to address the climate emergency. And Lobelia works with combining satellite data and computational intelligence, and they do so in order to assess different vulnerabilities, risks, but opportunities as well associated to climate scenarios. Laia and her team at Lobelia, they use open big data. They use free data from European satellites, and they are trying to monitor, to forecast and predict, and eventually to plan based on an environmental awareness. They have been collaborating the last years with a series of international organizations, among them UN Habitat, the World Bank Group, Oxfam, or the European Space Agency, among others. And we're very excited for the talk today because Laia will, I think she tried to combine a series of different projects that will drive us into the process of working with satellite data, working with big data, and deliver satellite applications that they are both relevant for climate policy, but as well as for planning. From IAAC side, we have a strong work related with our research in technology and working with big data for urban analytics as well as urban planning and design. So we are more than happy to have Laia opening up this online at the moment lecture series of the spring term. And Laia, thank you for being here with us. I don't know how digital clapping is happening, but I invite you all to help me welcome Laia Romero.
Thank you, Areti. Thank you. Okay, I think I see, this is quite new for me, the online format. I try to let me know if you cannot hear me well or if I can fix something with the connection. So without further ado, let's start with the lecture today. As Areti mentioned, I will be presenting the work of Lobelia and what we do to address the climate emergency. To start, I wanted to make a brief introduction around the terms of mitigation and adaptation, and a parallelism on the situation that we are facing these days. When we speak about mitigation, and I say this because I will be giving examples of both strategies. When we speak about mitigation, we speak about the causes of an event. So we try to take actions to reduce climate change, to reduce the greenhouse gases in the atmosphere. When we speak about adaptation, we speak about the impact. So how can we reduce our vulnerability to climate change? If we make a parallelism with COVID-19, which is a situation that we talk about all day, every day right now, and that we're living 24/7, a mitigation strategy, having known, and this is the important part, having known that bat populations are very, it's very common to find COVID-like viruses in bat populations, we could have put in place mitigation strategies such as preserve the natural habitat of bats so that they are that they can live safely far away from human populations, and so that diseases are not transmitted so easily. Or we could have reduced the probability of transmitting the disease by avoiding the trading of bats, or etc. So mitigation strategies, if we had known beforehand that that was a risk, that we did actually. An adaptation strategy, now that we are living in this COVID-19 pandemic, how can we cope with the virus? All of these are adaptation strategies. So if we decide to increase the budget on healthcare systems so that we have more beds in hospitals, if we strengthen the local economies, all of these are adaptation strategies that could have been also protecting us and making us less vulnerable in the past. I wanted to make this example because strategic thinking and strategic planning is key to climate emergency and to any type of emergency that we don't see coming so clearly. But science already has a lot of knowledge about things that are very likely to happen in nature and in relation to the Earth's resources. So the question of what would have happened if we had known that this was coming, when we talk about COVID-19, we are talking about a time scale that is what, like 2 weeks of like the incubation period, or a few months from the first moment the virus is transmitted into a human being, or even a few years if you want to build better hospitals. But when we talk about climate change, we're speaking about a time scale that is way broader. So we're talking about decades in the best case scenario. We're talking about 30 years time from now. And actually to start seeing consequences less, we're talking about 10 years, 20 years. We're already there, like every year counts. And so going back to what we do at Lobelia, we try to address climate emergency by providing data and information that enables these decisions, like to make the decisions of we are going to get ready for this because we learn about this, we know how this impacts our specific field of action, and we're going to take the actions needed to get ready for this. And a big issue that we find at Lobelia, and I think this is for every company that is trying to bridge the gap between science and society, is the fact that deep knowledge relies on basic science. And basic science is in love with specific problems. But it's very difficult to transfer that basic knowledge, that basic science so deep knowledge, into a day-to-day scenario. And the data, the information that we have about climate change today, and I hope this is changing, but so far is quite abstract. We know the trends, we know the warming, we know how the IPCC is telling us every 7 years with special editions every X years. Yeah, we can validate what we're saying. It is worse than we thought, or it is better maybe after the COVID-19 pandemic, but still, we know the bigger picture, but it's very difficult to know how, as an architect, since we are at IAAC, can I use this information, and should I apply this information when I am designing a new project or at a company, or if I start a business? Maybe you want to start a business brewing beer. How many years ahead can you rely on water for your beer brewery? So these type of questions are not so easy to answer. And this is what we do at Lobelia. And let me share my slides. I will be sharing a few slides and combining it with online demos of some of the services that we have operationally running and that are open. And yeah, let's go for it. I cannot share my screen.
Can you see the bar on the bottom, Laia?
Now I can. Now I can. I was disabled, but yeah, now I can. Okay. I think this is the one.
Yeah, we see now.
What do you see?
We see the presentation.
The presentation or my screen?
We see the PowerPoint of your presentation. So if you can go full screen in your PowerPoint, we will be able to see it.
Super. Now I see it too. You see?
Yes. May I ask you, Laia, because we now see your screen exactly as you see it. So we see the presenter's view. No problem, but you can change that setting into your PowerPoint. If you go into the view, I think, no, if you go into slideshow.
Is this better?
We see again this presenter's view.
Okay, let me try again.
If you go up where it says slideshow, in the next to the tools on the gray bar on the top. It's slideshow. Then I say yeah, exactly.
No?
Perfect.
Super. I had two screens. Okay, so let's move on. Who we are and what we do. So we are a company that is a spin-off from another company that is ISRTSAT. ISRTSAT is a world recognized expert in satellite altimetry specifically, and in new satellite missions in general. So since 2006, we have been developing algorithms to process satellite data. And ISRTSAT is an expert support laboratory of the European Space Agency. So this means that the algorithms that we develop are sometimes on board of operational satellites or processing on the ground what operational satellites are acquiring. And so we transform the raw data from the satellites into physical, geophysical variables that we can study. And some of the variables that we look at the sea level, the soil moisture, the a number of variables. So a couple years ago, thinking about this transfer between science and society and how can we make more use of the data that we generate, we brought together Lobelia, which is a new company now, and we provide and we deliver operational services making use of that satellite data that we call Earth observation, and applying the technologies and the methodologies that we know of, which is computational intelligence, that is physics, that is math, that is, well, everything that we do, space engineering, and so on. And we also build a very good team within Lobelia that is focused on communication and user experience. And this is super important, and you will see why. But to be able to communicate these complex data, sometimes visualization, good visualization interfaces are key. The things we do beyond building these data services, the platforms, the tools, running it on the cloud and building systems, is addressing droughts, fires, climate diagnostics, air quality, and more. I will probably be able to present our last project on plastic pollution on the ocean. And we always apply this scientific methodology, which is trying to base all of our work on evidence. And this is not easy when we speak about science, because I want to make a very short reflection about media here. We are contacted by media very often, and media are eager for highlights. And the problem with scientific knowledge or with any type of data is that it's very difficult to take it out of context. There is always conditions around a true statement, which is like, it's such a difficult thing to do or to say. And so this is our daily work, to be able to extract that evidence and then put it at the hands of somebody that will make use of it. So make knowledge useful. Just one slide on background information on satellites. When we speak about satellites, there are different types of satellites, communication satellites or geolocation satellites like the GPS, a lot. The ones that we use are the Earth observation satellites that are usually very large missions that are launched by Europe or by Japan, by the States, by India, by countries or groups of countries, and look at the Earth and cover the Earth every day. And the way that they work is that each mission has a different set of sensors on it. So there is a mission to look at ocean salinity and soil moisture, the same one, can look at both. And then there is another one that is looking at sea surface height. And there can be one that is only on temperature, and then can be another one that is looking at optical information, so imagery, and also has a temperature sensor. So each of these missions, and none of them last 40 years, look at something different. So we are at a point right now that is quite unique in time, because we start to be able to make use of long data records that have been built during a lot of years by merging all this information from the different missions and the different variables, building long data records that can be used for climate analysis and climate studies. So this is one point. And by the way, European satellites that are under the program Copernicus are free and open and are the third source of big data in Europe. So they are producing an immense amount of data every hour, actually. Then the variety that I was talking about, this makes it also big data and very difficult. Lots of satellites that measure different topics. And the veracity. Satellites are observing the Earth no matter what. And you have an algorithm that has been validated and that has been deployed and that works always on this or that configuration that you know of. So the information that you are collecting is neutral. There is no, we don't have a cross-border problem to acquire this or that data or to change the configuration or the calibration. What we see is what is happening. It's a neutral observation. And also the velocity. This is an example, Sentinel-1B, which is a SAR mission, has a rapid cycle of 7 days, but there are other missions that cover the Earth once a day, the entire Earth, or more than once a day. So I will be talking about air quality first, and then I will give you an example about climate diagnostics. So first, a baseline monitoring activity, which is air quality. And I want to start with this slide that has something to do with air quality and not directly, which was taken on August 25th by a European satellite, Sentinel-2. And it shows the fires on the Amazon area. So at that time, at that specific time, there were people, mainly the president of Brazil at the time, that was denying the existence of these fires. And I always like to put this example because that was a huge milestone for satellite technology. We showed, or it was shown, that the fires existed and a satellite was proving it. That was evidence. And this was so important as Google Earth back in the day when the population started to understand what optical imagery was and what happened if we had like sensors going, orbiting around the Earth, taking images that we could actually know what was happening at our doorstep. So another satellite that is not optical, it is Tropomi, and it is this one that you see here in the upper right corner. Tropomi is a Sentinel-5P precursor, and it is a mission, a European mission. The principal investigator is the Netherlands Meteorological Office, KNMI, and it gathers information on the atmosphere and gives us data on NO2. And I put this example because maybe you've seen a lot of these images in the news lately, because there's been a lot said about what Sentinel-5P sees from space during these days where no pollution or lesser pollution exists in urban areas. And so this has been used to show how the level of pollution in cities have changed. So how transit or traffic impact directly the air we breathe. And some of these studies are right. The ones with KNMI are right for sure. You can look for them. And there are many others that are right. But we have also seen some examples of using this data incorrectly. Although this data is collected once a day over the entire Earth, you need at least 1 week, averaging at least 1 week, to get rid of the high level of uncertainty in the measurement, and also to get rid of artifacts, to make sure that you are showing what's happening in that place, And so we should use, I mean, again, like knowledge about the way that we use the data is key to interpret it. So if we see what this satellite gives us at a city level, we see Madrid, Barcelona, and Sevilla. We see that the resolution is not so good, although it's quite good. It gives us a good approximation. And certainly a very good observation in places where there are no in situ measurements at all, and we wouldn't know what was happening unless we had this satellite in place. What we did in Barcelona and in Madrid and in Amsterdam and that we're doing in other cities worldwide together with KNMI, with the Netherlands Meteorological Agency, is they actually, KNMI, developed an algorithm that was using a dispersion model to try to interpolate what was happening between these gaps that you see in the slide. So the points would be the in situ measurements that exist, in this case in Barcelona. In other cities, there are way less in situ measurements, and trying to use other information, fill in the gaps to see what is really happening with air quality hourly at our doorstep. So we used the official air quality stations. We used the meteorological information, which is very important, and you will see later, the traffic intensity, population density, emission proxies, satellite data, and CAMS, which is the ensemble, the meteorological ensemble for Europe and other in situ data, to build an air quality service that you will see, here, that you can see here, that is running operationally 24/7. In Barcelona, in Madrid, and in Amsterdam, this is available, especially Barcelona and Madrid. And where you will see, and I will show you now, at every hour, how the air pollution changes across the city. And you can see also the 3 days before. You can also see, you can calculate your route if you're going by foot or by bike, and it encourages you not to take the car. Actually, if you want to take your bike from one place to the other, it will tell you what is the amount of NO2 you will be exposed to. And you can also see parks, playgrounds, and schools, and check the pollution around this area. And now I'm going to stop sharing my screen and share my browser, which is here. Okay, this is Barcelona, and this is in real time. You can click anywhere in the city. You see what we have right now, which is so very low. What we had at 8 o'clock, that was slightly higher, but really, really low for a weekday, for a business as usual Tuesday. And as I said here, you can also go to a specific place. I will not show it here because it will get a bit late. Okay. Right now you can very safely go around Barcelona on your bike without being exposed to NO2 pollution. And we can also see Madrid, for instance, which is also super low, even lower than Barcelona. It is raining in Madrid right now, and in the last couple of days. You can correlate very well the meteorological conditions with the air pollution in the city. And you see here how the main roads are always more polluted because the impact of traffic is super strong. It contributes a lot to the overall pollution. Also, when we speak about air pollution in cities, we speak about background levels or background stations and traffic stations. So when you read, and I will show you later, our report on the impact of lockdown restrictions on air pollution in different cities, you will see graphs of what would have been the pollution expected given the meteorological conditions we have right now on a business as usual scenario. So without COVID-19, without restrictions, and what you see right now. And when we do this analysis, we look at the background levels, which is the pollution that you, or the air that you breathe everywhere in the city when the NO2 has already been mixed in the air, so to say, so that you are not breathing the emission directly at the source, at one of these main routes, okay? Because it is very, very clear that at the main routes, when there is traffic, you breathe that directly. And as you go away, as you can see in the map, as you go away, this is dispersed. So if you are around San Juan Bautista in Madrid, depending on the area where you are, or the street where you are moving, you will be breathing more or less NO2. So let's go back to the slides. Okay, the impact of having done that. One of the things that we did once we started running operationally that service was to consolidate one data set. We took 2018 so that we had some leverage in terms of commercial value, to be completely clear. So we took 2018 and we consolidated one data set, meaning we looked at it, we validated it, we removed the outliers of the forecast, because in this platform we also forecast a few hours in advance, so we only took what was happening at every moment, and we shared it with everybody. This is free and open. It can be used by all of you, and you can access it through Observable. This link is available on our website. So this is an hourly street level NO2 concentration data set in Barcelona for one entire year, hourly. This data has been used by the team of Olga Subiros for the Pavilion of Catalonia in the Biennale of Architecture. And I do not know what is the status of that given the lockdown restriction, but I'm certain that they are working very hard on it, and it will be present in the next Quaderns edition. So this is an example, but many scientists used it, many people from different sectors used it, and that can only come back into feedback that will make it better. So if you happen to use this data set or any of our data and you experience anything, you find anything interesting, please come back to us. One of the teams that did this was Eixample Respira, which is a group in Barcelona made by different neighborhoods. Is a social entity that is fighting pollution, and that is bringing awareness into how polluted Eixample is. Eixample, well, at IAAC, I'm sure everybody knows what Eixample is, but it is a city center and there's a lot of traffic in there. And so they took this data set and they showed what were the schools that were more and less polluted, taking into account the time that kids were exposed to NO2, the levels of NO2 the kids were exposed to at the beginning when they entered school, when they go out from school, and when they are during recess outside. And so this brought a lot of attention of the media, and that helped actually. We were not involved in this, but we learned that they were using this data. They let us know, and they use this evidence to actually to make changes, to try to promote this behavioral change, and also to pass a law that that puts limitations into these pollution levels so that they are safer for the kids. Something else that happened is that because we started this hourly street level 24/7 service on NO2 at a city level, the local TV, the public TV in Catalonia started reporting NO2 daily as part of their weather section. So into the structural news every night and every afternoon and every morning. And this is one of the first times that this happens at this level, and it's huge because not everybody is ready to deal with this data, and they are pioneers in this, and there are other TV channels and radio stations that are also taking these sort of actions. This is very important because it is clear impact on society and how knowledge is being transferred from science into all the different steps to the citizens. Something else that happened is that this data can be used to assess action plans now, as the low emission zones in Barcelona, the super blocks, or any other action plan of something that we want to do in the city. In Barcelona, in Madrid, we already have an advantage right now, is that we have seen what it is without the traffic. We have a load of data that will be very interesting to analyze. And then we move from air quality. I will go back to it to finish today's lecture, but I want to show you first a bit on vulnerability. Vulnerability to climate emergency and how to address it. Adaptation, 100%. Let's go to the past Climate Explorer. We started working with UN Habitat a year and a half ago, more or less, because they had a city resilience tool and a city resilience program in place. And this team of UN Habitat, which is the Urban Resilience Hub based in Barcelona, are very hands-on, have this program in place, and they go to the different cities and study how we can adapt to climate change. Let me see, maybe because the time is, okay, no, we're okay. Okay, so we started working with them, and the first thing we saw, we went to Korea and had a huge meeting there, a workshop with users from all over the world, from every continent, and all these people were saying, that is what I want. I want to be able to know exactly what I should do to protect myself from the climate emergency, but I don't have any data. I don't have any information. Some cities like Barcelona, New York, Copenhagen, everywhere, even everywhere actually, big cities or most of the big cities have a lot of data, but others do not have any data. And so we built the Past Climate Explorer to start communicating what we were trying to implement. And I will show you right now. Okay, this is the air quality, and this is the Climate Explorer. The Climate Explorer shows us the entire world. Okay, now it is set in Barcelona. And you can see, this is the I cannot speak, the climate stripes, where you see very clearly the trend in temperature and how it changes from cold to warm. And this shows from 1979 to 2018. You see precipitation patterns, you see rainy days, relative humidity, wind. And when you click in any city in the world, anywhere, you see the same graphs. Because we have a very good coverage of the Earth with remote sensing data in combination with reanalysis models, which is what I am showing right now. And this was eye-opening to a lot of people that decided to join this sort of program, because they could see their city, they could see how these trends were actually true to them. They were directly represented here. And then we would start the discussion on, okay, so what's next? What are the projections? And what can you do to address these climate crises that will affect you in this particular way? If we go back to the screen. What we did was to build a Lobelia climate sort of engine that is feeding into UN Habitat CRPT, the City Resilience Program tool, that is looking at every single aspect of the city, urban planning, sewerage systems, anything around the actual city, collecting documentation at the city council and training the teams at the city level, and then producing the plan for resilient action that can be done at a city level, and this can be also done at a regional level. So that was a good example of how cities were using this type of data. What we did, and I don't want to go into it too much, is that we downscale the data by taking these global models and downscaling it with other information, such as the satellite observations, but more information. You can also do it with in situ observations or with reanalysis models when you don't have any other thing. And then take the global model and land it at a local scale and see what that trend means at that specific city, because there can be significant changes in terms of the warming, the actual levels of the warming, or the number of rainy days or frost days, or specific stresses and shocks that can only be seen when you zoom in. Okay, these are on the web, but here you see a couple of examples. One is in Asunción, in Paraguay, and the other one is Yakutsk in Russia. And both city councils were involved in this and developed their own action plans with UN Habitat using this sort of data. Okay. We also deliver the assessment with key messages and the actual data with values, so that we don't only say increasing frequency of hot days so that there will be an increase of heat health impact, but we try to actually put a number to that to know the threshold where you are moving. And so that more studies can be done on top of that to say, okay, heat health impact, but what? Are we talking about viruses, actually? Are we talking about something else? You can actually narrow down a lot using the data. Okay, so that's it. And I want to quickly show you what we did for COVID, which is very much alive, and we update every day. Here. Okay, this is the page. Lobelia.earth, COVID-19. Okay, you can see here, this was done by the Royal Netherlands Meteorological Institute and Lobelia. And we compare here the before and during the lockdown. And to do this, we average the data in 36 hours, I think, by 36, in a moving window of 36 hours. You can check actually the levels by time, so that at 8 o'clock you will see how polluted this was before and how it is right now. And what is before? What is before? Before is before the lockdown. We cannot compare what we are living right now with another week last year or with another month last year, because the meteorological conditions, and this is what we found in our analysis, change everything in terms of how the air pollution exists, or during how many hours the air pollution exists on the ground and is not dispersed. So what we see, and this is Madrid, same thing. If we look at the animation, we see how the 2 weeks before, and now we will actually include a couple more weeks in the before to make it more balanced, the pollution was higher. And when we started the lockdown, it started decreasing. But during the first week of the lockdown, we still didn't see major changes, because even though the traffic was reduced, heavily reduced, the meteorological conditions were so favorable that it was not scientifically correct. We didn't have hard proof, so to say that this good air that we breathe today is because of the lockdown restrictions. However, as time passed by, we actually collected enough evidence in order to say that pollution levels on the background levels, so away from the very main roads, so the levels that all the city is breathing, have gone down more than 32 or 33% up until today. And we can see that on these very specific routes, even the change is even higher, because we see the clear contribution of traffic directly. We can say also that right now we breathe, the air we breathe inside the city in Eixample is as good as the air that we breathe outside of the city, where usually we have a very good air quality. Madrid was different, because they were in the middle of a pollution peak, or the first days where we would have had high, or we would have expected high pollution levels because of the meteorological conditions. But the lockdown restrictions were clearly very visible, because pollution levels decreased rapidly, even though the meteorological conditions were not favorable for those levels of pollution. And here you can see in yellow the in situ measurements at the background stations of NO2, and in black what we would have expected with the meteorological conditions, so the forecast but in a business as usual scenario with the activities as normal, okay? You can also see the impact of traffic, and you can also see the impact in other cities. There is Rome with a very big difference due to the lockdown restrictions, Milan, and Paris, and so on. And here, that's it. I will stop sharing my screen, and I hope that it was not too boring and that we can move to questions and comments.
Thank you very much, Laia. Thank you for a deep insight of understanding not only how we can use satellite and remote sensing, but also what kind of conclusions we can have, and how science will somehow, let's say, support how we transform data and numbers into information and knowledge, as you were saying. It was very interesting also to hear you saying that, and very relevant as well with what we're living today, that science already has a lot of data that if worked appropriately, then we can have predictions and know with high accuracy what is possible to happen in terms of natural phenomena, or even in terms of pandemics as the one that we are experiencing right now. And before giving the word to the people that have been following us the last hour for some questions, I wanted to raise, let's say, a topic that it's related with the difference between monitoring and forecasting, or monitoring and predicting, because I know that you have a series of other projects that time today was not enough to share with us, but projects that are not only monitoring in real time contamination data. Actually, when you from Lobelia Earth opened up the contamination data about Barcelona, there was a party among us that we were actually searching for this data. So it was a super useful action. But I think that a big part of the work that you're doing is also related with how from this amount of big data we can actually create models, algorithmic models that can help us predict what will happen in agriculture, in cities, in mobility, in contamination, and so on. Maybe you can share with us
exactly
words about this.
Yeah, that is absolutely correct. So on the climate diagnostics example at the different cities, what I showed is that using the data from the past and the monitoring data, we can adjust the predictions so that the predictions are actually also adapted to that specific region. But there we are using projection data. And then on the air quality, we also use forecast data because we forecast the following 2 days of air quality, but a very clear or a couple of very clear examples of the way that we use the satellite data for prediction or forecasting is on the water resources. When we look at drought and when we look at floods, for instance, flood modeling uses our water level from lakes and rivers. It assimilates this water level in order to improve their prediction, because in many, many places remotely, we don't have any in situ data. So satellite data is key for that, and we provide forecast alert systems. And for drought, the same example. So you're absolutely correct. We go from past to present to future.
Thank you, Laia. I will try, well, actually, maybe I will openly ask if there is anybody that wants to address any question to Laia in a direct way. I mean, I know I asked you to write it to the chat, but I think that we can also try to have an interaction that is not necessarily moderated by me. Matilda, yes, go ahead.
Hi. Hi, Laia. How are you? Welcome to my home. I was really interested in what you were discussing about this question, or this idea of bridging the gap, or this challenge of bridging the gap between deep knowledge and basic science, and how you can communicate that between or how you can render or facilitate the communication between science and society. And I know that from IAAC's side, we are making a lot of efforts to be able to do that. So for example, in our Master in City and Technology, we're working at the intersection of urbanism, so a design or a city scale design, and data science. So combining these two things. But I was interested also in a reflection, you know, there's a lot of reflection going on about how we need to adapt educational models in this current moment because of the isolation situation. I was wondering if through your research and development, you had made any conclusions or reflections on what is the adaptation that design education, adaptation of course, that design education needs to fulfill to be able to bridge this gap between science and society already from an earlier stage, let's say.
Okay. Okay, I would say first, we need to acknowledge, and I think that is happening, that we cannot forget about the fact that, there is science beyond anything or behind anything that we do. So the first thing is to be able to know what is the actual data, and data is key, that we will be able to use and how. But the how is the difficult part. If you have an agricultural team, okay, developing a project, agriculture, advanced agriculture, before having a data scientist in place, they may want to consult a meteorologist, meaning it is not easy to run data-driven models. It is not easy to build them or to build an experimental design that is actually going to give us the right information that we want to look at. Because with data science, and we have data scientists in the team, and it is a big part of our core, but it is more important to have the perspective on the right criteria to actually know how to use these tools than to actually build the tool very quickly. And this is the important part. And this is why we will keep having jobs as long as we know how to program machines that will do that job a lot. But we need to know how to set up these experiments. And for that, we need the different disciplines. So interdisciplinary, super important. And scientific criteria, I don't know what happened here, but there is, but we should be teaching this at school from the very beginning, and also in design school, scientific methodology. For me, that is, I mean, that is, I am a very, I'm a fundamentalist on this aspect.
But I know you are.
But that is my perspective.
Okay.
We
fantastic.
are indeed fond of science here. We will agree with you on that.
I think you are. Yeah, I know you are. Sorry.
Bringing science to the very basics of education and scientific methodology is a key to innovation to start with. Mm-hmm. No? Okay, anybody else that wants to?
Hi there, I have a question.
Go on, Srey.
Hi there. First of all, Laia, thank you so much for your presentation. I found it super interesting because my thesis kind of has the same skeleton to what you were presenting. So I had a question with regards to the part where you talked about collecting information in between. You have specific stations dotted throughout Barcelona, and then you talked about finding out what happens in between those stations. So I found that part really interesting, and I hope you could elaborate on what are the kind of trade-offs in terms of the resolution of information that you get in between And what are the, how do you kind of seamlessly blend the high resolution of the stations and the in-betweens to form conclusions on the data that you get? I hope that made sense.
Okay. It is sort of like if you run a free model, a free run of a model, and then you try to adjust it to the observations that you see on the ground. And so in between these, you will have a field that comes from your free run that you will need to adjust, and then you will do it with more information. There is a paper, I can share a paper with you from Bas Niglin, I think. I don't pronounce his surname well, but he's a collaborator of Lobelia, and he's the one that we developed this service with. And there is a paper with the methodology that can help you.
Oh, excellent. Yes, I will be in touch with you then for sure. Thank you so much.
Thank you. Thank you.
Maybe we'll invite Laia back in June to see some of the projects that you guys are doing. Anybody else?
I would love to.
Yes, I have a question, please.
Yes, go ahead, Daniel.
You were talking on the municipal level that you were giving out information to, let's say, the municipality, or even in the level of small communities that were using all the data. Can you give examples maybe of like what happened with that, if any project emerged from that, or how did the community use it? Like in the end of the day, okay, I know that I have a problem of, I don't know, emission in the air. What did they do with it, with this data? How did it empower them, or what happened with it? Also on the architectural way level.
On the
do you have examples
way?
or do you know?
On I know of projects where this data is used for the infrastructure design, for instance, by architecture firms. And also I have participated in proposals run by architecture firms where they require this type of information as an input to their feasibility designs. I am an oceanographer myself. I'm not so, I don't know so much about architecture, but it is clearly used in the terms of, in the case of the cities, this has been used for urban planning, for instance, to decide that the city center of a city has to be moved slightly because of the flood risk in the next 30 years. So it's been decided that the city, or a city like in the case of Jakarta, for instance, that the capital changes because of many reasons, but climate reasons are also taking a big part in that. So urban planning use it all the time.
Mm-hmm. Okay, thank you.
In terms, yeah.
I will just add, like, again, for us, after we graduate IAAC and we go, all of us, to our home countries, for me, myself, I would really like to implant all kind of information like this in my projects for the common good, and of course for our future. So this will be also, I guess, something that we'll need to see and interact at the day that will come. So thank you for sharing.
Now we need to find ways that stakeholders, decision makers, use the physical data. This is the thing, because it sounds very good on paper. It sounds excellent, like an excellent plan. But then people need to actually change processes in the organizations in order to make that knowledge useful.
Yeah.
And yeah, and so as architects or as any other jobs, the interesting thing is that we talk together and that we find this way. Like, how specifically in this process can I use this data and what is the best data that I can use.
And
Thank
also,
you.
I mean, if I am allowed to add to that, it's very powerful, the fact that with these technologies, we are able to also assess the impact of a plan or a proposal, no? And especially when we're talking about urban planning or architectural, let's say, design, it gives us the possibility to simulate and be able to understand what the impact would be of certain proposals. And that's why,
yeah. Now I'm thinking of, for instance, with a bridge, like what is the value of a certain bridge in terms of their life, of the life of this bridge, like how long will this bridge stand on its own, given the fact that there's a river underneath and there will be a flood risk of this much during these many years. This is something, this type of thoughts, I think it's important to put them into our designs as well, because it sets up a basis of where we need to go, like taking what's in there right now and how we're moving from that to something new that it is different.
Laia, I will now come to you with a question that comes from some people that they are following us on Facebook streaming, that they were interested to learn more about the projects that you have done in relation to plastic pollution and how satellite data can help us to identify these risk areas and how to work with this data.
Okay.
Just to say also that maybe we can, I can also pass the link of your project into the chat so that more people can also have access to this project that you didn't have time to show.
Clara, who's our communications manager, is here. I think she has access to the chat and is sharing some links. We have a couple of projects going on that are closer to research, in this case, on plastic pollution. We are part of an expert group that studies the feasibility of new satellite missions to track pollution, to identify pollution and understand what are the sources and sinks of this plastic pollution in the ocean. This is super important because we know that a couple of rivers account for most of the ocean pollution, ocean plastic pollution right now. And in terms of policy, it would be great to be able to monitor that and to be able to report on that. Also, we do not know where and how much plastic is sinking into the ocean floor. But we know that every time right now, and this was not the case 15 or 10 years ago, right now, every time somebody goes into the Mediterranean with a trawl and collects sediment, find microplastics in it. And the number of fish that contain plastics is also extremely high. So in the face of all of that, we started thinking satellites can do something. But then what sensors, as I was explaining before, an optical sensor doesn't see through clouds. And it is very difficult to make the picture exactly when the plastic patch is, because it is moving. So unless it is so big that you will be catching it as the satellite moves in every picture, then that very rarely happens. It's very difficult. But we can go with hyperspectral that do better with this type of conditions, but cannot see in depth, the water column in depth either. So this gives us, like, every sensor gives us a flavor of what you can do. And now we're trying to think, what would be this satellite mission like in order to track the pollution? And our part on this is on radar. as I said before, our expertise relies on this type of instruments. And what we are doing is collecting on one side, well, I will just explain this one. We have another project that you will find out later in a couple of weeks, better surprise. So what we are doing right now with the project in which we are working right now is we are collecting SAR data, synthetic aperture radar data, around the Balearic Islands to start. We collaborate with IEO, which is the National Oceanographic Institute of Spain. And they have in situ data that they have collected for many years, for more than 10 years. And we try to look at the SAR images with machine learning techniques, trying to find patterns in the image, not necessarily to identify visually, but to find patterns in the backscatter received or in polarimetric channels in different ways to identify plastics. We are trying to push the SAR technology in that regard. And we know that probably the most interesting thing that we will get out of this project is to know more about the uncertainties and how we need to focus on this, because this is such in an early stage. And it is it's much more flashy and attractive to say, yeah, we are identifying the plastic. We are doing research and we are looking at the ocean and we are trying to extract information from that. So in a year from now, I'm pretty sure we will be able to explain a lot more on what radar data can do for the plastic detection on the ocean, thanks to the computational intelligence techniques, the artificial intelligence techniques that we will be putting into place by processing thousands of images. I don't know if I explained it well or not.
There are some parallel chats happening with people asking a lot of information, so we're trying to answer everybody. But thank you for your answer. And is there? I mean, we can have a couple of questions more. Is there anybody else that wants to share something with Laia?
I wouldn't mind asking a question.
Sure, Alex, go ahead.
Hi, Laia. Thank you so much for the insightful yet again presentation. I actually found out more things about what you guys do, and I have to say I've been a fan for the past year and a half that I know what you guys are doing. I've been speaking from my personal experience. Literally, what you have done is what we have been missing in order to really understand the contamination levels in Barcelona, and especially within the Master in City and Technology, every year there is this recurring theme of how can we know exactly the resolution of the city, in the city level of the contamination of Barcelona. So hats off to you. And now my question is, I'm more interested in your opinion on this, because I see a very big analogy between climate change and COVID. And I don't want to exactly turn the conversation towards COVID, but more towards coordination. And this is not something that I usually talk about, but I think it's really difficult to avoid, in the sense that what we have seen in the challenges towards climate change and regulating, bringing all this international community and measuring data about air pollution and atmospheric contamination, is that there's a very, very big importance, a fundamental importance in harmonizing data collection. No? So as an international community, we need to kind of have some guidelines to all follow. Otherwise, everybody's tracking their own data in their own way, and it becomes a mess. And this actually really became apparent with COVID. Especially when you started seeing deliberately underreported data, lack of coordination between countries, duplication of data. Now, that is one very, very important thing that in the climate change, sort of in the atmospheric tracking community, we know this from experience. No, there's been a lot of years trying to come up with this, the fundamental sort of foundation that everybody can track. And thankfully, there's been a lot of progress, even though there's a lot of political sort of pressure against this. But aside from that, what can we learn for today? And this, I ask you as a monitor, right? Somebody who has experience in monitoring data. And I'm specifically asking this question because I saw in your slideshow that you are actually working with the United Nations to actually introduce these guidelines. So what is the challenge in actually doing this coordination, this international coordination of measuring? How much, let's say, part of your, let's say, thinking process does it actually take? How does it affect your measurement process? And what can we learn from this to actually better address the measurements, the collection of measurements for COVID?
Okay. Thank you for your question and for your comments, and thank you, Alex, for your support, because it's great to hear that what we do is useful, and we're very happy that you actually use it in your program. So you're very right on point, so much that there is a note in Nature in the last issue that speaks about how the IPCC is coping with coordination under the COVID situation, and how we can do everything remotely or not, or how governments are changing the priorities to continue with the IPCC work or not, and a bit like a discussion, an open discussion on how this is happening, because the coordination aspect is clearly an issue, and we have learned that COVID-19 has opened our eyes in so many ways, and like the fact that something like that can happen has opened our eyes, and I think that that we should all be aware of that and reflect upon it towards whatever comes after. So in that note in Nature, they explain that the only thing that they ask for is that governments and administrations learn something from this COVID-19 situation and apply this to the strategic planning in climate change. And this is the only thing that all scientists are agreeing upon, because between scientists it's quite easy, I would say, to collaborate. ISRTSAT is involved in a project, INBI, that brings together, I don't know, Clara, I don't know it by heart, but more than 40, 50 organizations, entities, academic entities. I think we are the only company in the entire world.
Maybe more.
Yeah, in the entire world, collecting data on the poles and understanding the past evolution and what will happen in terms of floods in the future. And we have a couple of Natures co-authored by ISRTSAT in this aspect. So at a scientific level, people collaborate. Now, between administrations, that is the difficult part. Not even in COVID, we see a coordinated action. Administrations, I don't want to get too political here, but administrations are saying, you didn't do this well, or you that, or you, I mean, it's so not there, this coordinated action. And for climate change, this is absolutely right. It is necessary. It is necessary. So we need to work together, and governments need to establish agreements like they have so far, but farther in terms of the strategic planning. So it doesn't affect us in research, I would say. It can affect us commercially, maybe, not so far, but I imagine if all governments would be like, yeah, let's use the data, how would that be? Like, we need collaborative action in place for that. Coordination is key. So,
and what about transparency? Because what is also happening, I was surprised that you saw the project of the climate, I don't remember the name, where all the earth could be seen, and then you can focus into the different cities to see the different data, and all countries have agreed or have participated into that. And then we know that 7 million of people annually die due to respiratory problems, that they are being created by contamination, air contamination of both exterior air and interior air inside the buildings, which are not always healthy. So there are a lot of millions of people dying every year based on because of contamination. And I wonder, whereas transparency is something that leaders are willing, let's say, to give away, especially after a moment like that we are, recording deaths due to respiratory issues, and then we somehow, it seems that we forget there are so many millions of people dying every year because of things that we can definitely change as decision makers. So are the leaders willing to give transparent information about the data of contamination?
Yes, so in our experience so far, yes, administrations are very open, but we are working in Europe with air quality, or in other countries. One example was what happened in China. We started this project in China and in India. And in China, the administration was was always given the same information and was quite straightforward. But what happened was that we found out that there were inconsistencies between what we saw from the satellite and what we saw on the bottom up, on the in situ, on the inventories that people put together, collecting all the information from the different sectors. And with the scientists there and the meteorological agency there, we saw very clearly that these inconsistencies do not necessarily mean that the top down from the satellite down is wrong. It means that you need to look at that place and check what they are doing, because many people are not reporting the right information. And right now, China is very much advanced in that, because air quality was causing a lot of deaths. So from that time up until now, we've seen a great evolution, but that was a good use case for us to realize, oh, okay, like our data is actually providing this neutrality to some scenarios that are where this is important. And it will happen everywhere. I said China, but I don't like to say China. It's everywhere, actually, in every country.
Sure. Okay. If there is any last question to Laia, now this is your moment. Otherwise, we will need to close this session. Anybody wants to last comment?
Do you listen me?
Yes, please. Go ahead, Xavier.
Oh, hi. First, I would like to thank you very much for all this conference and all this talk. I mean, I live in Lleida, and it's a pleasure to listen to you. So thank you very much for streaming it online. Well, my question is not related to climate change or this directly, but it's a question directed to how we can use that technology to improve our lives. Because of course, using satellite and all this technology to focus, to combat climate change and all these aspects is very crucial. But I would like to ask how we can prevent violations of privacy, or how we can prevent corporations or governments to use that technology, that important technology, to maybe violate our privacy or violate our security. Thank you.
I don't have an answer to that, Xavier. I agree with your concern. I think that we need to vote to the people that will do better in that situation, that we believe each of us will do better in that situation. And we need to keep being alert and know about what we do, and actually do not how to say, like, again, like the scientific criteria, the critical thinking. Like we should promote it, we should keep having it, and be active in our society, because what you are saying, it is a risk that exists, and exists with, I don't know, we will, if we need an application to track COVID antibodies, this will be super helpful for the scientists, but obviously there is a B side to this, and we can only push for this application to be developed. And we were discussing this with the team, with ISRTSAT and Lobelia not long ago. We can only push for the right, or what we think is the right people to develop this type of tools, and to be very aware of who we are voting for in positions of power. But I'm afraid that actually when somebody in the team would say is the blockchain technology. Go for technologies that protect us from this manipulation and violation of our identity and rights. Blockchain is a great example of this, not because of the coins, but the actual technology. Let's move to that, but then let's put pressure and be active into developing that, testing it, validating it, that I think is, we are past that, and deploying it into all sorts of systems, because this is a very good way to go. I mean, as technology, on the technology side, that would be an answer. I don't know. Sorry not to have like one super clear answer, but at least these are my thoughts right now.
But I think that is also a great way to close, Laia, like thinking the way that we manage our resources and we manage our society, and bring in technology to have more transparent transactions with blockchain or similar technologies. I think it's a good way to deal with everything that is related with data privacy at a moment that in reality we have no privacy at all. And at a moment that all shows that this privacy is very fragile. So instead of trying to avoid to be with in any navigation, let's say, platform, what is better to do is to rethink the way that these data are being managed. So just to say a huge thanks, first of all, to Laia, that have been very, very kind to participate with us in this online lecture. I wish it could be different, but still I think it gave the opportunity to have a lot of people connected from different cities and parts of the world. So I would also like to thank the almost 200 participants here in Zoom, and also Facebook, LinkedIn and Twitter with the live streaming, and also your active participation to the questions. I hope that science and as well as from our side, architecture and urbanism, every time more and more starts to use this open data in order to better understand the environment, and therefore take more informed decisions, planning or design decisions. So Laia, thank you very much, and I wish you everybody a lovely night, and stay tuned for our next lecture, which is in 2 weeks' time.
Thank you very much for having us and sharing this time as well. Thank you. And I hope we have dinner after this.
Exactly.
Because we were supposed to have dinner after the lecture, so I'm
I owe you one. I owe you one, Laia.
No, it's just a joke. Thank you very much. It was our pleasure. Thank you.
Thank you.
Thank you. Thank you very much.
Bye.
Bye, everybody.
Bye.
Bye-bye.
Have a lovely evening. Bye-bye.